Hey, it's day 86 of our keeping our trails paved. Let's get going. So yesterday, last lesson, we found the area. We reviewed all of the different formulas and recipes that we have, and we're going to do that again today. So what is the area? We've got to figure out what that shape is, and then we got to pick up that recipe card and apply the formula for this. So that shape is a parallelogram. So we're going to use the base times height equals area formula. The base is 25, the height is 19, and that gives me 25 times 19, that gives me 475. How are we going to label it? With the squared. We just found out that there's 475 little squares inside of that, if that were drawn to scale, huh? Okay. 2 lessons ago, I gave you the area. You had to find either the base or the height. Again, we start with the correct formula, right? If this is a triangle, then we're going to go with 1/2 area of a triangle is 1/2 base times height. We have the area and the height, so it's the base that we're going to leave by itself in the formula. The area is 4.86 equals 1/2 times base times 1.8. I'm going to take half of 1.8 and get 0.9 times base. Now, how am I going to figure out what that base is? Well, I'm going to do the exact opposite of times, which is divide. And then to keep things equal, I'm going to do the exact same thing on the other side. And I'm going to pull out my trusty calculator, 4.86 divided by 0.9 equals 5.4. B equals 5.4. Just yards. Because I just wanted to know the base, not the area, and the base is just a straight line. Now, I could check that, and I could put that into there now, and I could easily, on my calculator, just go 0.5 times 5.4 that I found as the base, times 1.8. If it is correct, it'll give me the area is 4.86. Shall we see? Boom, we got it. So I know I checked it, and I know that that is the correct base for that triangle. 3 lessons ago, we did trapezoids. Trapezoids are 1/2 base plus base times height. So we're going 1/2. My 2 bases are the ones that are parallel with each other, so that'll be 5 plus 9 times by my height is 4, 1/2 times 14 times 4. Half of 14 is 7 times 4 is 28, labeled with a squared. 4 lessons ago is a triangle, 1/2 times base times height would give me, oh, my light just went off. It doesn't think anyone is in here. You like that? Okay, so 0.5 times 4 times 4 times 6.5 equals 13. 13 meters squared. Booyah. Ooh. And then 5 lessons ago, we found the area of parallelograms and squares and rectangles, which is just base times height. If you want to get super technical, the area for a square is just your side squared. Here's what I mean by that. One side is 9, right? What is 9 squared? 81. Now, if that's too much for you to remember that extra formula, you can still do this. Your base is 9, your height is 9. You still end up with 81. So whatever works for you, you get 81 centimeters squared though. Write an inequality for the situation. Carlos's mom will give him no more than $10 to spend on snacks. No more than $10. Carlos's mom, don't you know how much snacks cost now? So what is that inequality? Remember, inequalities are these and these and these. So Carlos's mom So his mom will give him, what will she give him? She might give him 10, right? She could give him exactly $10, but it's not going to be more than that. So it's going to be less than $10 or exactly $10. That's how much she's going to give him. So it's the less than or equal to sign for that inequality. 5 lessons ago, we solved for S. How do we solve for S? We isolate the S. How do we isolate the S? We do the exact opposite. We do the inverse of whatever is going on. What's the opposite of divide by 3? Times by 3. And then because this is an equal sign, we got to keep it equal by doing the exact same thing on the other side. So do you notice that I times by 3 and then I times by 3? Because I did the exact same thing, I can keep my equal sign, which means that S equals 18 times 3 is, I guess I have a calculator, don't I? 3, 4, 5, 54. Boom. 20 lessons ago, we found equivalent expressions. The question is, are these two equivalent? Remember, equivalent means the same. Are these two the same? Well, like looking at them, there are some differences to it, right? This has parentheses, this one doesn't. Is there anything we could do to get them exactly alike? Well, hopefully you can see the angry bird, right? The common factor in the pigs. So let's distribute the pain. Distributive property, 6 times P is 6P. Bring down the plus. 6 times Q is 6Q. So are those the same? No, this is only Q. This is 6Q. So we're going to say no, they're not the same. What is 2600ths? 600ths as a simplified fraction. We can't do this because they're not both zeros, are they? So we could divide by 2 though, because they're both even. That'll give us 13/50ths. And 13 is prime, so I can't get any simplified. So that's a simplified fraction. The decimal is, maybe I'll do it the percent first, because I know 26 over 100 is just 26%, right? And then decimal to percent would just be 2 scoops over for 2600ths. Feel good about that. I like that I did the percent first and then went back to decimal. That made it a lot easier for me. What two integers does -3/4 lie between? Integers. Have you heard that word? Anytime in the last 60 lessons? We better review. An integer are whole numbers and their opposites. So all of these are integers. So what does -3/4 lie between? Well, it's a negative, and it's not yet. So like 3/4 is this much, right? So it's not yet at 1 whole. So that means it's between -1, but it's bigger than 0. So it's something more than 0, but it's not yet at -1/2. So it's between -1 and 0. If we're on a number line, here's 0, here's -1, here's -2. It would be right here, between 0 and -1. Do you remember that integer word, or is that like a synapse that was like weak? It was like, I know I've heard it, I don't remember what it is, but now you remember. And you're like, oh yeah. Okay, Jacob is putting 18 nonfiction and 30 fiction books on bookshelves. Each shelf will have the same number of books. What is the greatest number of books for each shelf? Wondering just because of that word greatest number, if it's a greatest common factor problem. So would finding the greatest common factor help us answer how many books for each shelf? Well, let's try it. 18 and 30. 6 will go into each of those. 6 times 3 is 18. 6 times 5. 3 and 5 don't have a common factor. Okay, so 6. What is the greatest number of books for each shelf? 6 books on each shelf. Jacob is putting 18 nonfiction and 30 fiction books on bookshelves. Each shelf will have the same number of books. What is the greatest number of books for each shelf? Yeah, 6. 6 books on each shelf. Because they have 6, 12, 18 nonfiction books, so 3 shelves for nonfiction, and then 6, 12, 18, 24, 30. So that would work for the fiction as well. So yeah, 6 books on each shelf. Yes, I'm glad I saw that greatest number. That kind of gave me a clue there, huh? Okay, there you go. Good review, friends. See you later.